In question for part B, C, D and E, we've been asked to calculate the effective annual rate of interest corresponding to a nominal rate of 12% per annum, compounding at different frequencies. So the way that I calculate that is I use the following formula. And let me explain the intuition behind it using part B. So what we want to do is we want to work out what the interest rate per period is. So for example, in part B, it'll be 12% per annum compounded monthly. So I take my 12% and I divide by 12. And what that's giving me is an interest rate of 1% per month. Now to find the effective annual rate, that will need to compound if it's monthly 12 times. And then this expression here is equivalent to saying if I invest $1, earning an interest rate of 1% per month, compounded monthly, that will give me the value of my investment at the end of 1 year. If I subtract the $1 investment, then all I'm left with is my return. And this is my return in cents if I invested $1, but it's also the effective annual rate of interest when the interest rate, the nominal interest rate is 12% per annum compounding monthly. Now, if we look at part C and we apply that principle again, we need to work out what the interest rate is per period. So now it's weekly. So divide the nominal rate by 52, raise it to the power of 52, subtract 1. In part D, we follow the same process, 1 plus 12%. It's daily, so work out the interest rate that applies per day, so 12% divided by 365. And then in a year, there'll be 365 compounding periods, and then subtract 1. Now, in part C, if I put that into my calculator, I get 12.73%. And in part D, I get the effective annual rate of 12.75%. So what you can see is as the compounding frequency increases, the effective annual interest rate increases because we're compounding more often and we're earning more interest on interest.